In this video, we are going to learn about very important topic of networking, which is networking, which is network reference model models. So we have two models, which are OSI model and TCP model. So why do we require these model? We require this model because earlier the interoperating between products from different vendors were seems to a challenge. To overcome that challenge and provide consistent standard, we require network reference models. Means earlier we were having IBM PC. They require IBM keyboard, IBM memory space, IBM processor, IBM motherboard, IBM chips, everything. But later on, there are vendors who were creating the same type of things. They were not able to perform and configure their things with IBM processors. So that were the challenges for them. And to overcome these challenges, l- most popular organizations like IEEE, INA, ISO, DoD, etc., have invented these models. So to learn about this model, how a data move from source to destination, in which standards and what protocols they follow, it become very important to know about these. So let's just discuss about OSI model and TCP model. In OSI model, we have 7 layers. First is application layer, then we have presentation layer, then we have session layer, then we have transport layer, then we have network layer, then we have data link layer, then we have physical layer. These are layers of OSI model, which are 7. But our data travels like while following these layer concepts. So we have a PDU concept in understanding this layer, which is protocol defined unit. At different layers, we call our data with different names. So at physical layer, we call it as bits, 0101, like that. Then frames, Ethernet frames. Then we have packet. Then we have segment, and altogether these are data. The upper 3 layer are called upper layers, also known as user layers. The lower 3 layer calls lower layers, as well as network layers, and this is establishing connectivity between these two set of layers. Transport layer. In TCP DoD model, these 3 layer altogether forms our application layer. Transport is layer is the same. Network layer also same. also called an internet layer, and these two called network access layer. So let's understand the OSI model by taking an example of visiting a website. Okay, so let's say whenever you visit the website, you open a browser, then you type the URL, let's say www.icici.com. Then application layer receive the request and send the query to DNS server to provide, because it has the host name icici.com. So the DNS server will then ask mail exchange server to provide the IP for the same host name. Then our application layer generate request toward presentation layer कि please take charge of the data which I am having. It is having the host name, the URL, address, IP address, etc. Then, then the presentation layer create format. Presentation layer creates format. For example, here it use port 80 because it is HTTP data. Then presentation layer tell session layer, please take over the data which I am having. So now the session layer do run some protocols and check the connectivity and number of session to reach from source to destination. So all those work is done by session layer. Then the session layer tells it adds a level 4 header and submit the request to transport layer to check whether the connection is connection oriented or connectionless. We have TCP UDP protocols here and check error detect on the basis of IP. If it found nothing wrong here, it submit request to our network layer, and network layer add level 2 header in the data and give it to the data link layer. Then data link layer header reads the Ethernet frame and create the data in the format of bit and create the data. I mean dismantle the frame in the data and submit the request to physical data to convert the whole data in bits. Then our whole data reach from application layer to physical layer. So what happened in while processing this is encapsulation. Encapsulation is the definition of encapsulation is request generated from application layer moves toward physical layer on each and every layer, which added extra header information in PDU from layer above the processor is called encapsulation. So encapsulation is adding layer from application layer toward physical layer in the format of PDU. Now let's just understand what are the protocols we are having on different OSI model layer. So let us first take application layer. As I told you, it is an interface between a user and the network. So the protocol in application layer are FTP, TFTP, STTP, SSH, IRC, etc. So these are the protocols which are application layer protocols. Then we have presentation layer. Presentation layer is having protocols like MP3, JPEG, MPEG, MIDI, encryption description protocols, etc. And these are approved by ASCII, means American Standard of Coded Information Interchange. So we have different port here in these protocols. Now we have session layer. In session layer, we have protocols like SCP, which count number of session between source to destination and to maintain a time on user system. And second, we have NFS. It is a network file system developed by Sun Microsystem for Unix platform. Right now, you just need to understand to learn few of them, and the more we will go deep dive into the concept of computer networking, we will learn each and every protocols. SQL also lie in this layer. Then we have transport layer. Transport layer is having TCP, UDP, etc. It detects the error which comes from internet, etc. Then we have session layer done. Then we have network layer. In network layer, we have protocols like IP, IPv4, IPv6, RARP, ARP, etc. ICMP. These are very common protocols. Then we have data link layer. In data link layer, we have protocols like HDLC, ATM, triple B point to point, etc. In physical layer, it it is of it is responsible to verify electrical and mechanical specification of each and every interface of devices. So these are the very basic understanding which you should hold about the OSI and TCP model. The very important thing which remains lack here is understanding why do we use these both, where do we use these layers or concepts. So first of all, let's understand the uses of these layers, uses and differences use of uses. So TCP and OSI model. OSI model is hexa-based model, hexa-based, and it is used for mainly troubleshooting the network issue, troubleshooting. So we do troubleshooting with the help of this OSI model. And the routing protocol here is ISIS, which is hexadecimal based protocol. In TCP, we use it for checking the standard of devices. We have TCP model for protocol standard. It is binary based, and all routing protocol like RIPv2, EIGRP, OSPF, BGP, etc. comes here in this model. So now let's understand one more thing here. It is, what is the difference between a routed protocol and routing protocol? A routing protocol do not carry the data from source to destination. Rather, it create path from source to destination. For example, we have RIP, we do all the routing protocol there. EIGRP, OSPF, BGP, IS. These are dynamic protocols. This is also dynamic. So these are the routing protocols. They create the path, does not carry data, no to data. Now in routing protocol, it carries data from one end to another. The example of these protocols are IPX, SPX. IPX is Internet Packet Exchange, and SPX is Sequence Packet Exchange. Then we have TCP IP, Transmission Control Protocol and Internet Protocol. Third, we have Appleton. It is for Macintosh. So these are the routed protocol and routing protocol. Routing protocol create path, does not carry data. It create it does not create path but carries data. So this is the difference between routing and routed protocols. In the next video, we will understand basics about IP addressing and your subnetting. Then we will move to routing. So thank you guys for more such videos. Please subscribe the channel and do let me know if any improvement you want in my teaching. And this is just for knowledge transfer base. So please do take use of it. Thank you.